GMM stands for Gaussian Mixture Model, and the next topic is support vector machine. So our first topic, that is Gaussian Mixture Model, means it is actually a probability distribution model. So we saw that in the previous case it was actually based on supervised learning algorithm, but here Gaussian Mixture Model is based on unsupervised learning or clustering. Unsupervised means there is no teacher or there is no target, and it will not try to achieve the target. Instead, points which are coming close together while plotted, that will be forming a cluster. That is, the points which are having the same type of features will be coming close together, so that can be taken together like a cluster. So it is also called as expectation maximization clustering or EM clustering. That is another name for Gaussian mixture model, and it is also based on the optimization strategy. Optimization means we are trying to achieve the best possible value. So the advantage of a mixture model is that it need not belong to a particular subpopulation. We need not say that it totally belongs to one subpopulation, but maybe it belongs to part by part, or probability that it belongs to this particular group. This has highest probability, towards this cluster it has less probability, and so on. The main thing is that it is based on unsupervised learning. So we know that a Gaussian distribution, that is something that we have already learned in maths. It is same thing as the normal distribution. It is another term for normal distribution, which is a bell-shaped curve, and around the y-axis, actually equally it is divided. The area on either side is going to be equal. So this is the formula for the probability density function for a Gaussian distribution or normal distribution, where mu stands for mean in this equation and sigma stands for standard deviation. So in Gaussian mixture model, what we saw, that is the equation that we saw previously, was corresponding to one Gaussian curve. Now if we are having a Gaussian mixture model means we are having several Gaussians and each of them will form a cluster like this. That is, all the blue points will be basically belonging to the blue cluster, the green points will be basically belonging to the green cluster, and so on. That will depend upon the mean and the standard deviation, which like we have seen in the previous slide. So here there are three clusters, so k will be equal to 3. The value of k will be equal to 3, and how much amount it will be mixed, that is the mixing coefficient pi k, means the probability that it belongs to any of one cluster. That is, if we are taking one point, so what is the probability that it belongs to the red cluster? Then what is the probability that it belongs to the green, and what is the probability that it belongs to the blue cluster? So to each one of them it will be having one particular probability, but when you add all these probability, then you must get that equal to 1. That is, if you have a particular point, we need not say that it belongs to one cluster alone. We can say that it belongs to several clusters with different probabilities, but when you add the probability, you must get that value equal to 1. So that is meant by Gaussian mixture model, and this is the equation for Gaussian mixture model, which is actually an extension of the Gaussian equation which is given here. It is slightly modified with higher dimension, with d stands for the number of features in the data set. So here instead of root 2 we will be having d by 2, where d stands for the dimension, and then this is expressed as a matrix. So that is how this equation has been extended for a Gaussian mixture model, where we will have several normal curves. Next is another algorithm which is totally different from Gaussian mixture model. This is called as k-means algorithm. K-means algorithm means, imagine we have this blue color point and we have got 3 clusters like this. So what we will do is we will calculate what is the distance from this point towards the center of this cluster. So whichever point, whichever center has the minimum distance towards that point, we can say that the point likely belongs to that particular cluster. For example, let us assume that this is the shortest distance. Then we can say that the blue point actually belongs to the blue cluster. It has more chance over there. So what is the difference between k-means and Gaussian mixture model? First of all, k-means calculate the distance, whereas Gaussian mixture model will calculate the weight. Weight means it will take into account the probability also, and Gaussian mixture model will be more accurate. And k-means is only calculating the conventional Euclidean distance, whereas GM is better because it considers the standard deviation also. Here you can see this is just calculating the distance from the center of that cluster, where mu is the center, x is the point or the where it stands in the 2D plane, and you're just calculating the distance using this formula. Whereas for Gaussian mixture model, you are considering this term in the denominator, which is the standard deviation. So you're considering the weight also. So this means that this will be a more accurate, it will give a more accurate representation where the point will belong to a particular cluster or not. So we can say that the Gaussian mixture model is better than the k-means algorithm. So Gaussian mixture model has another name. We saw that it is also called as expectation maximization algorithm. So some more points based on that is again written. And these are the advantages of Gaussian mixture model. That is, it is more flexible and it is more robust, and we can get the data relatively very fast. Then you can handle the missing data, all that. So all these points you can read. Also along with that, there are certain disadvantages of Gaussian model. All this has been asked for previous university also. Then applications of Gaussian mixture model. So basically Gaussian mixture model means it will be asked for a 14 marks or something. So you will have to first explain what is Gaussian mixture model with the diagram and the equation. Then you have to explain the advantages. Then you have to explain the disadvantages, and then you have to explain the applications. Even though it is not asked in the question, if you are asked to write for a 14 mark question or for a 12 mark or 10 mark, you have to basically cover all these topics. So next is support vector machine. Support vector machine means we have already seen what is meant by a supervised learning algorithm. So let's go to the figure, and using that figure I will explain. So imagine this is the set of points corresponding to all the cats. Okay, if you have a set of images which is corresponding to cats, I am going to plot all the cat over here. So all these green dots represent various cats, and all these blue dot are going to represent various dog. So we know that cat and dog belong to different classes. So I am going to divide that using a plane. Okay, using a line or using a plane, actually I can divide that, and this means that it is having maximum distance from these two classes, and this will be the most accurate plane that divides exactly between these two classes. It is not towards one class or it is not towards another class. So here what we are going to do is, so this is called as the decision boundary or the hyperplane. So this decision boundary will give us an idea, an exact idea between the exact point where it can be classified into two plane. So this is called as the negative hyperplane, and this is called as a positive hyperplane. and this will give us the maximum margin. So these 2 points, if you can see these 2 points at the end of each of these class, they are called as the support vectors. They are called as the support vectors because if it cannot be moved. Actually, these 2 points define, this is exactly where you can divide between the cat and the dog class. This is also an exact point where you can divide between the cat and the dog class. So you can take the distance between these 2 support vectors and divide the plane exactly in the middle. So you will get the exact, even if some points come over here, it is okay. So that is why these 2 are called as a support vector. So support vector machine means they will give us the extreme points beyond which if you go, then it will go to the other class. So these 2 points are called as the support vectors. So these extreme cases are called as support vector, and hence this algorithm is called as a support vector machine, because beyond that if you go, if a cat is placed beyond that, then it will go to the dog class. That is how it is considered. So the goal of the support vector algorithm is to create the best decision boundary, and the best decision boundary, we saw that if these 2 are the support vector, then it has to come exactly at the middle. That is, this is the points which are actually crossing through the support vectors. If you're taking the distance of that and if you're dividing it by 2 and drawing a plane between that, that is called as the best line or the best decision boundary. So we can correctly categorize if any new point is coming using this plane. We can correctly categorize if it is going to come in the cat or if it is going to come in the dog plane. So this is just an example. You need not mention explicitly as cat or dog. I just use that for you to understand. You can say class 1 and class 2 instead.